Herzlich willkommen zur 23. JAX. Präsentiert von Entwickler.de. Begrüßen Sie den Program Chair Sebastian Mayen.
Herzlich willkommen. Herzlich willkommen. Servus München. Servus zu Hause vor den heimischen Bildschirmen. Wie schön ist es, euch wieder alle hier begrüßen zu dürfen in diesem großen Saal. Wie schön, dass ihr auch remote dabei seid. Wir sind weiterhin eine Hybridkonferenz mit so vielen Leuten, die gleichzeitig auch remote uns hier folgen. And please give a very, very warm hand to Diana Montalion.
Thank you, Sebastian. Thank you. So good morning. As he said, I'm from New York, and if you know what today is, you know I am very happy to be here this morning. Yeah? So this is also me. I started as a back-end engineer, and I helped build the digital monoliths, and I'm not sorry. It was the right thing to do at the time. But increasingly, as I moved into more leadership positions that I had more responsibility for both the code and the process, I'm the person in the doorway, trying to figure out how to turn around and contribute something helpful when the world around us was becoming so increasingly complex. And so we went from coding in a single piece of a single piece of software, and adding customization and customization and customization and thousands of lines of code. And now we think about microservices and event streams and event-driven and continuous deployment. And instead of building software, predominantly what I'm doing, what a lot of us are doing, is building systems of software in order to handle the complexity. So the idea for this talk planted in my brain in 2019, where I was speaking at an architecture conference, and a young man sat down at the table, the lunch table, and looked at my badge and said, "Oh, you're an architect. I want to be an architect too, but I don't know enough about Kubernetes yet." And I thought of my experience over the last 20 years, and I wished that Kubernetes was the problem. That if I just knew more about Kubernetes, then I would be fine. But actually, this is my primary problem, is that increasingly I'm being asked to do digital transformations and modernization, and you know all the buzzwords, and we'd start off great, and then we'd hit the iceberg. So what is the iceberg? What I had to survive, become increasingly interested in why. Why were organizations struggling to change? And so I'm going to give you a fictitious example that's in my book and that I use in workshops. But when I say fictitious, I mean based on a true story. I mean based on many true stories. I mean you probably will recognize at least some of the pain in my experience. So the company is Mago. Mago was originally the biggest print publication in the world. So read everywhere. And their system looked basically like this. Writers put content data into a monolithic software. Designers designed the layout. There's a relatively complex system underneath that printer's box. And then images were on the side. They actually talked on the phone about images. So I'm not really sure how that worked, but and then they had a vendor that managed the subscribers and the mailing lists. So then they needed a digital presence like everybody did. So somebody wrote an export script to translate the XML. No one knows anymore who wrote the script, but it worked for a very long time. But the transformation didn't fully translate. So they began to need a manual help in order to move from context to context, and we introduced the concept of what I call the minions team. And then they needed another vendor to manage digital subscriptions because, of course, the interface to check a digital subscription is very different than a mailing list. And the subscriber, there wasn't any software that did both, so there's another script that sort of kind of integrates who the users are across this system. Then they needed an app, which needed more hand massaging. And then some content producers started writing digital-only content. So now we have a fork in the system when you look at the data underneath, because the digital content doesn't flow backwards. And so now we have two systems, a print system and a digital system that has the subsystems, but then you need digital marketing, right? Because now that's a completely different world. So there's a social media team in the basement. They're all under 25, and they use only their own tools. So it is all cutting and pasting. And then we needed newsletters, but you don't need a subscription to get a newsletter. But they, of course, want to track who is engaging with their product. So now the digital subscriptions is also sort of newsletter subscriptions. And if you can imagine the data model that is being built for each potential user, also if you know that if you use 2 or 3 different email addresses, how much disambiguity there is now in that system. Then they needed multimedia, completely separate teams, completely separate softwares, software parts, more minions. And then, this will be a shock. The product owners and the product people started getting frustrated because it was so hard to build new products in this team. So they went, in this system, they went rogue. And they started hiring external vendors to build software completely dissociated from the original software. And that's how product development started to come into this system. So if you ask the CEO about Mago's digital transformation, this is what the CEO would say. Now, in the modern world, we can create once and publish everywhere, right? That one person can create information, and that information can reach users. Now, the thing about Mago is reach is really important, because if somebody interacts with some of their content across multiple platforms, they're likely eventually to become subscribers, and they stay. But the content is created all over this system, and none of it flows backwards, and much of it is siloed. Where is the source of truth in this system? Now, you don't need a source of truth if it was a decoupled system that had bounded context, but it isn't. It's more like a duct-taped Rube Goldberg machine. So then, increasingly, machines are reading the content. Machines for Google and language models and Apple News and Facebook Instant Articles. And where do the machines get the right structure and understanding of Mago's digital information? So what will transform this system into the vision that the organization has for the modern world? It isn't probably Kubernetes. Right? It's a very valuable tool, and it is probably part of the solution, but all my Kubernetes skills in the world don't really help me to figure out what to do that will have an impact on this system. So what architecture skills do we also need? So the first thing I want to say is that architecture, as I'm describing it today, is a practice, not necessarily a job title, not necessarily somebody who gets to make all the decisions, but instead, it is a quality of a system. It is a quality mostly of the people system. Because in fact, in order for us to design systems that we are part of, we all need to be at least friendly towards some of these practices so that we're able to create a system that does what we want it to do that's new. And so they're faced with a systems challenge, so Mago needs systems thinking. So we're educated to think linearly. When you think of the word thinking, this is probably what comes to mind. Linear thinking is rational, top-down, predictable, procedural, and concerned with control. You can't build software without linear thinking, right? This is not a talk that says that's bad. It is very necessary in many circumstances, but it isn't the only type of thinking. And Donella Meadows says that systems can't be controlled, they can only be designed and redesigned. So when we're moving towards systems design, we're moving away from hierarchical focus on control, and we're increasingly trying instead to have impact. We want to be able to contribute recommendations that will have an impact on the system as a whole and push it in the right direction. And so this is why it's a bit of a challenge that we often think of it as a promotion role, and it can be, but it also is a practice that we're practicing often regardless of what our primary responsibilities are. So when we're faced with systemic complexity, we practice reductionism. Object-oriented programming is reductionism. It's breaking complexity into parts so that we can focus on the parts. And so software silos, for example, bounded context. So the trouble is that reductionism doesn't work the other way. It doesn't help us understand how those parts form a system. And for that, we need to apply the types of thinking that help us to understand systems. So for example, we need to think about the interconnection between the parts, how the system works together as a whole, because the CEO is actually describing the goal of the system as a whole. We synthesize knowledge and information, meaning as we're faced with complexity, we can't possibly understand all perspectives in the system. There's the business perspective, the product's perspective, the user's perspective. There's performance and scalability. There's how the experience is to build and write code. And so instead, we are learning constantly from other people with knowledge and experience and integrating it with our own to try and understand how to have impact. But the most important thing is that we understand relationships, because in systems, emergence, that's a really big word. It's a very popular word. And it means that when, for example, if you have one person that can do a thing and another person that can do a thing, emergence is when those two people can do a thing neither of them can do alone. Same with software parts. That you have two software parts in a silo. From a systems perspective, the question is, what do those two parts in relationship, what do they do that they cannot do alone? And so we focus on relationships. This is the heart of systems design. And again, Donella Meadows says that you think that because you understand one, that you must also understand two, because one and one make two. But you forget that you must also understand and. And is the art and science of systems design. And in fairness, to some extent, the control of and across multiple different dimensions of time is part of what tools help us to do, tools like Kubernetes. Russell Ackoff says that a system is never the sum of its parts. It's the product of their interaction. So if you're having the experience where you need to design the ability for 2 pieces of software or 3 pieces of software or 749 pieces of software to interact and speak and share knowledge, then you're already deep in this practice. So MAGO contains many good but independent and uncoordinated ideas. I suspect that most of you have seen software systems that can be described as this. I would say most software systems I've seen in the last 25 years look like this. This is what Fred Brooks describes as the antithesis of conceptual integrity. So he says conceptual integrity is the most important consideration in systems design. And what he means by this is that as architects, we're designing concepts. Concepts is a key word. It is our ideas, our plans, and our intentions design the system. And if we can't create cohesion in our thinking, in our design skills, then we can't create cohesion in our systems. And so understanding that relationships produce effect. When you are having a problem that is, say, an outage in production or other kinds of organizational challenges that are just incredibly maddening, usually the call is coming from inside the house. Most systems are generating the problems that they're solving. And so understanding how relationships in your current system are generating the effect is just as important as understanding, if you're designing or modernizing a system, how relationships produce effect. And not just relationships in the tech. That software systems are socio-technical systems. Everything in production is what we thought and what we talked about. And so the relationships between the people who think about and design the system, how we think together, is what we will push to production. And so what we know and what we think, they're inextricably wound up in our code. And our software systems mirror our people systems. Organizations who design systems are constrained to produce designs which are copies of their communication structures. Here's MAGO. This is exactly how they've organized their teams. This is also how they were thinking at the time. Type of asset, type of media asset. That's what designed their system. And this is an endless loop, right? Because also, we are asked to do things with technology tools like Gen AI that it cannot do. It's just like magic, right? And so we are constrained by knowing and understanding the limitations of technology. We're constrained in what we can actually think to do. And that informs our thinking, and then our thinking informs the tech, and it's an endless cycle. So it requires a culture change, not just from MAGO as an organization, but also from us. I guarantee, if history proves itself true, that at least some of you will say, this is too abstract, Diana. This is too abstract. Concrete. If I had $1 for every time someone said concrete to me, I wouldn't have to be here. I'd be reading my Kobo on a beach. This is concrete. In fairness, this is cement. Concrete is an even more complex system where you add water and sand and rocks in just the right amount. So this is really a matter of a shift in perspective. I do understand 25 years of people asking me to do something, telling me to do something that's not possible in the physical world, right? And I get being tired. I get people saying, oh, here, I've made this decision for you, go and implement it, as if that actually works. And I also get it because when my head is deep in the code, I am not thinking about relationships between parts outside of my own parts. And so when we're designing systems, we're partnering cross-functionally, horizontally, to be able to get other perspectives on the system. Why does this matter? If we say we need the system to be performant, why? What is the impact on people, on the system itself that we're trying to gain? But the same thing works along the y-axis, up and down the micro-macro scale. We don't have to be constantly working up and down the entire scale ourselves, but we do form relationships in the technology teams that help us get a picture, a broader picture and a wider picture. And that it's not a binary, we're synthesizing these perspectives. In other words, they both matter, they both inform. It's an endless loop. What the code can do and what the system needs to do is an endless stream of decision-making about how to have impact. Pirsig says that the true system, the real system, is our construction of systematic thought itself, of rationality itself. And it helps me, on the harder days, to keep in mind, we made all this up, all of it. We made up conference events, we made up Kubernetes, we made up Agile, we made up DevOps, we made up AI, we've made it up. And when those concepts no longer fit our world, we can evolve them, right? We needed Agile to solve some problems, now we hate Agile, so we throw that out, and yet when I hear people talk about how much they hate Agile, I don't hear that those problems got solved. I feel like we're kind of throwing the baby out with the bathwater rather than evolving. Okay, that was of a time, what does this time need? What do we know now that we didn't know then? And he said, if a factory is torn down, but the rationality which produced it is left standing, then that rationality will simply produce another factory. You may have had this experience. When my team and I moved from monolith to microservices, our microservices were very tightly coupled. This was a surprise to us, but our brains were tightly coupled. So we had to work on being able to think in an asynchronous world after having a lot of experience writing queries to save to a relational database. And that rationality lives in our own minds, right? We have lots and lots of ideas about how this should work and how solutions in one circumstance that we want to apply in a new circumstance. We need to be re-architecting our own thinking continuously, really before we can make an impact on the world around us. And so I adapted Conway's law to say that people who design systems will produce copies of their thinking and communication patterns, right? So the same thing for me when I moved from more linear queries to asynchronous queries, I had to update my thinking patterns, and I also needed to update what to worry about, because the problems I used to have didn't help me anticipate the problems that I was about to have. And it also means that I need to communicate in different ways at different times because our way of communicating was very linear. Too often, we really aren't thinking about our thinking or communication. We're giving our opinion. Now, I have a lot of opinions. And I made the mistake last time I was on stage of sharing one, and afterwards 5 people came up and asked me why I didn't like SAFE. So I'm not going to do that this time. But opinions are totally fine, especially at a conference, but they aren't architecture. And that's really important to remember, that Mago doesn't need more opinions about what to do. I guarantee inside the Mago organization there are more than enough opinions about what to do. Instead, they need well-constructed, well-architected, cross-functional solutions that have a positive impact on the system. This is something we know from decades of systems science. As complexity increases, and as people get unsure about how to handle or manage the complexity, we blame, which would be great, except we blame the wrong thing. I bet you can guess what we blame. The other team, the other people, leadership. The deep state is the new thing in the US, by the way. Elon Musk said that the reason that they had a 45-minute outage in a system that wasn't designed for the thing he was trying to do with it was deep state. So that's my new excuse. Late for a meeting? Deep state. So this requires us to accept uncertainty as natural, welcome, and inevitable. This is probably easy, right? Because your organizations are just all about uncertainty, right? Totally for it. No one's trying to have control or certainty. This is snark, if you didn't recognize it. This is a very difficult mind shift. But we learn this from continuous learning. And I don't work in any of the same tools I worked in 5 years ago. And 5 years ago, I was working in tools I wasn't working in 5 years before. In the course of my life, I've experienced 20,000 years of change, the equivalent of 20,000 years. It's changing so fast that we're always changing with it. And we don't just blame the wrong things, we do the wrong things. So Jay Forrester is a systems scientist who spent decades and decades studying systems and organizations, and he discovered that people who know a system are often pushing the change in the wrong direction. This is called counterintuitiveness. Of course it is. We're using the minds that caused the problem to solve the problem. That's fine, that's inevitable, that's what we do. But when we are in the middle of it, we're often contributing to the noise, right? Our goal is to contribute signal, meaningful recommendations that address systemic change. And the challenge is that our initial reactions will always, or almost always, be blame and counterintuitive. And so we as individuals are developing the skill to take a step back, shift towards responding, and be able to use systemic reasoning to help develop a recommendation, to be part of signal. Systemic reasoning is reasoning systematically in support of an idea, action, or theory. What you're looking for, because uncertainty, is the best possible conclusion under the circumstances when conditions are uncertain. Conditions are always uncertain. It was kind of delusion that we thought. Also, under the circumstances, can't just do what Netflix does. Unless you happen to be a streaming service that has exactly the same organizational structure as Netflix did, then you could do that. So instead, you're synthesizing, you can't do it alone, you're synthesizing knowledge and experience, and you're using sound judgment. What will actually matter? I call it the cup holder conversation. We're trying to figure out what the engine needs to be in a car, and everyone wants to talk to me about the damn cup holders, right? So we are using our ability to, as we do this practice, to also be able to draw out the things that really matter to any particular situation. We do this by making recommendations that share an idea, action, or theory, and we justify them with reasonable, well, reasonable isn't the word, but I'm going to add that because that's probably right, with reliable, relevant, sound reasons. It takes time to develop a recommendation. It really, it's way harder than you think. And why does this matter today? I tell the story in an architecture meeting, a fellow architect or re-architect, we need Kubernetes, we need Kubernetes. Why? And he rolled his eyes at me and said, because we don't have Kubernetes. Now I get what he meant, right? Like, I understood enough to see. But we have to be able to articulate among the 7 million decisions, budget decisions that are getting made, why does this budget decision matter today? Why are we investing in this? What will it improve in the system? And also, what is the impact we're trying to have, and how will you know if you have it? And this is tricky because something else will happen. You'll never get exactly what you, well, maybe never. I've once written a line of 1,000 lines of code and ran it, and it ran the first time. In 20 years, that's happened to me one time. So you might get something that works out exactly the way that you intend. And in order to do that, you need to structure discovery, learning, and exploration with others proactively, right? Leveraging the fact that you probably work with a lot of really brilliant people who probably have knowledge and experience that can expand your own. Also, they can help you strengthen the reasons, help you show something you might not have considered, help you see a perspective that will help the recommendation have a bigger impact. If you want to learn more about how to do this, there's a great talk in Atlanta right after this, where you learn and also get more resources for doing it. So then, of course, Mago needs people good at building tech, right? Our expertise really does matter, right? Our ability as system scientists, whether that's by delivering the code or designing the relationships, our actual tech skills are why we're here. So while you're here at this conference, you're going to learn a lot of valuable up-leveling for your technology skills. And as you go through it, I just want to ask you to imagine what you can accomplish with these practices plus your technology expertise. I wrote a book. It's available on the O'Reilly platform and Amazon. It will be coming out in German, but I don't know when, and an audiobook. Also, if you visit learningsystemsthinking.com, I'm developing with others a practice community, newsletter, a library of resources, of talks and other things that help us to think in systems. Yeah? Have a great conference, and think of me tomorrow morning when I wake up and have to look at the news.
Thank you. Thank you very much, Diana, for this great start into the conference. And now it's just my pleasure to lead you out to the coffee break and to the next sessions. We meet again after lunch break for the next keynote. Enjoy the many sessions we're preparing for you. Enjoy conversations and have a good time. Thank you so much.
Thank you.